Serverless computing has emerged as a game changer in the world of cloud technology. Unlike traditional models where developers must manage servers and infrastructure, serverless computing allows you to focus solely on writing and deploying code. The cloud provider takes care of all the underlying resources, scaling, and maintenance. This means you only pay for what you use, and you don't have to worry about server management or capacity planning. Serverless computing is gaining popularity because it reduces operational complexity, lowers costs, and speeds up development. Whether you're a startup or a large enterprise, this model offers flexibility and efficiency, making it easier to innovate and respond to changing business needs. Let's dive deeper into how this technology works and why it's transforming the IT landscape. Serverless computing brings a host of advantages to businesses and developers. First, it eliminates the need for server management, freeing up valuable time and resources. Automatic scaling ensures your applications can handle sudden spikes in traffic without manual intervention. The pay-as-you-go pricing model means you only pay for the compute time you actually use, which can significantly reduce costs. Serverless also speeds up development cycles, allowing teams to deploy new features and updates faster. Enhanced security is another benefit, as cloud providers handle infrastructure-level protections. These advantages make serverless computing an attractive choice for organizations aiming to boost productivity, reduce expenses, and stay agile in a fast-paced digital world. While serverless computing offers many benefits, it's not without its challenges. One major concern is the so-called cold start problem, where functions may take longer to respond after periods of inactivity. There can also be complexity in managing costs, especially if usage patterns are unpredictable. Security remains a shared responsibility. While providers secure the infrastructure, developers must still protect their code and data. Integration with legacy systems and vendor lock-in are additional hurdles. Despite these challenges, ongoing advancements in serverless platforms are addressing many of these issues, making the technology more robust and accessible for a wide range of applications. Serverless architecture is designed to simplify application development and deployment. In this model, developers write small modular functions that are triggered by specific events, such as an API call, file upload, or database change. These functions run in stateless containers managed by the cloud provider. Key components include serverless functions, API gateways, managed databases, and object storage services. The architecture automatically scales resources up or down based on demand, ensuring optimal performance and cost efficiency. By offloading infrastructure concerns to the provider, developers can focus on building innovative features and delivering value to users. One important concept in serverless computing is the cold start. This occurs when a function is invoked after a period of inactivity, requiring the system to initialize the execution environment before running the code. Cold starts can introduce latency, which may impact user experience, especially in real-time applications. To mitigate this, cloud providers use techniques like pre-warming or keeping instances ready in memory. Understanding and managing cold starts is crucial for developers aiming to build responsive and reliable serverless applications. Function placement refers to where serverless functions are executed within the cloud infrastructure. The location can impact performance, cost, and security. For example, running functions closer to end users can reduce response times, while distributing workloads efficiently helps prevent bottlenecks. Advanced techniques like machine learning are sometimes used to predict load patterns and optimize placement. Proper function placement is essential for achieving the best balance between speed, efficiency, and resource utilization in serverless environments. Serverless computing uses a pay-as-you-go pricing model, where you are charged based on actual resource usage, such as function execution time, memory consumption, and the number of requests. This model can lead to significant cost savings, especially for applications with variable workloads. However, understanding the pricing structure is important to avoid unexpected expenses. Some providers offer volume discounts or different pricing tiers. By carefully monitoring usage and optimizing code, organizations can maximize the cost efficiency of their serverless applications. Autoscaling is a standout feature of serverless computing. The system automatically adjusts the number of function instances based on incoming requests, ensuring optimal performance during traffic spikes and cost savings during idle times. This dynamic scaling happens without manual intervention, allowing applications to remain responsive and efficient. Autoscaling can be horizontal, adding or removing instances, or vertical, adjusting resource capacity. This flexibility is a key reason why serverless is ideal for unpredictable or rapidly changing workloads. Scheduling in serverless computing involves allocating resources and determining when functions should run. Effective scheduling ensures that critical tasks are performed on time, resources are used efficiently, and delays are minimized. Advanced algorithms such as real-time and multi-objective optimization are often used to manage complex workloads. By prioritizing functions and optimizing resource allocation, scheduling helps maintain high system performance and cost-effectiveness, especially in environments with diverse and time-sensitive tasks. Serverless computing is making a significant impact across various industries. In e-commerce, it powers recommendation engines and streamlines payment processing. Healthcare organizations use serverless to analyze medical data in real time and monitor patient conditions. Media and entertainment companies rely on it for video streaming and interactive content. Financial services benefit from improved transaction management and security, while transportation and logistics firms use serverless for real-time tracking and fleet management. Even education is transformed, with online learning platforms leveraging serverless for scalable, personalized experiences. There are many platforms available for developing and deploying serverless applications. Open source options like Apache OpenWhisk, Kubeless, Fission Native, and OpenFIOS offer flexibility and integration with Kubernetes and Docker. On the commercial side, AWS Lambda, Google Cloud Functions, Azure Functions, IBM Cloud Functions, and Oracle Functions provide managed environments with automatic scaling, event management, and seamless integration with other cloud services. The choice of platform depends on your project's needs, programming language preferences, and existing infrastructure. Serverless computing and traditional computing represent two distinct approaches. In traditional models, IT teams manage servers, configure infrastructure, and handle scaling manually, which can be time-consuming and costly. Serverless shifts these responsibilities to the cloud provider, enabling automatic scaling, reduced costs, and faster development. The pay-as-you-go model replaces fixed infrastructure expenses, and developers can focus on building features rather than managing hardware. While traditional computing offers more control, serverless provides greater agility and efficiency, making it ideal for modern, event-driven applications. Serverless computing is even more powerful when integrated with emerging technologies. For example, combining serverless with blockchain enables secure, decentralized transactions and smart contract execution. In the Internet of Things (IoT), serverless functions process data from connected devices and scale dynamically as device numbers grow. Artificial intelligence and machine learning models can be deployed as serverless functions, allowing real-time data analysis and prediction. These integrations open up new possibilities for innovation, efficiency, and security across industries. Future of serverless computing looks bright with rapid advancements on the horizon. Adoption is growing across organizations of all sizes, driven by the need for flexibility, scalability, and cost savings. Cloud providers are continuously enhancing their platforms with better management tools, improved security, and performance optimizations. Open-source frameworks are making serverless more accessible, and integration with AI, IoT, and other technologies is enabling smarter, more efficient solutions. Addressing challenges like cold start delays and management complexity will further improve the user experience and expand serverless applications. Serverless computing has fundamentally changed how applications are built, deployed, and managed. By removing the burden of server management, it empowers developers to focus on innovation and delivering value to users. The technology's advantages, cost savings, scalability, and speed, are driving its adoption across industries. As serverless continues to evolve and integrate with other cutting-edge technologies, its impact will only grow. Understanding both its strengths and challenges is key to leveraging serverless for future-ready, efficient, and secure digital solutions.